Our last video for this module will be adding and subtracting rational expressions with denominators that do not match. But remember what I told you on the last video? I want you to think of it again as the same process no matter what when you see the words adding and subtracting. So when it says to add and subtract, remember we're getting the LCD, we're building them to match. Once they match, we keep the denominator, we add or subtract the numerator. Once it's a single fraction, that is the only time we're going to factor the numerator and see if something cancels. Biggest mistake on these is y'all start the problems correctly, in the middle you start undoing it. Do not cancel numerator and denominator until it's a single fraction. It has to be multiplication, remember, to cancel. So we're going to start off with number 15. So the first thing you have to recognize, and again remember we're picking one specifically to point out things, is that we need to first rewrite that as 4 over 1. So looking at this, my LCD for this problem will be x. And remember, I want to keep that once I get it. As long as I multiply both the numerator and denominator by the same value, I'm not changing the value, I'm changing what it looks like. So to get my LCD, I'm going to multiply the top and bottom of this second rational expression by x. So I have 5x plus 4x over x. So we're done with step 1. Again, remember, once I get my denominators to match, I'm going to keep them and I'm going to add across. The mistake people make here is they add things they're not supposed to. We add the like terms, and I always suggest putting it in descending order. So looking across here, I have 4x plus 5. I can't add them, they're not like terms. If it helps, put a parentheses at this point because I cannot factor anything out of that numerator, so nothing cancels. That is my answer. A lot of y'all will want to cross out the x's, and that's why I suggest putting the parentheses around that binomial in the numerator. Remember, anytime you need to pause, go ahead and pause. You can rewind. Go ahead and try to work something out yourself. So looking at number 16, first thing we have to do is figure out what my LCD is. These are monomials. Okay. The 7 and 6, there's nothing in common. There's no common factors of those, so we're going to multiply them together. And we do need just one A. That part already matches, but we have to keep it. Remember, we take the biggest amount that happens in one of them. But my goal is to make them match. The A has to be included. It already matches. So my goal is to get 42A. So I'm going to multiply the first rational expression by 6 over 6. Again, you can use your calculator to multiply this out. 15 times 6 gives me 30. That will give me 90. So 90 over 42A. Second rational expression, I'm going to multiply by 7. Numerator and denominator. That gives me 56 over 42A. We're done with step 1. Denominators match. We want to keep that. So 42A. We are going to add across the numerator if we have common terms, which we do. 90 plus 56 will give me 146 over 42A. Once it's in a single fraction, we ask ourselves, can we reduce anything? So again, y'all have a calculator, you have that ability, but for example, right now, I can actually at least know that it's divisible by 2. So if I divide it by 2, that's going to give me 73, and then the denominator, that's going to give me 21A. Looking at this piece here, the only things that could work would be a 3, and a 3 isn't going to work, top and bottom, or a 7. So that is my answer. So now we're going to go to number 17. Same idea. Build the LCD. Again, pause it, try to see if you can work through it. My LCD for this problem should be 5D, and we want to keep it. So I'm going to multiply this first rational expression by 5. That's going to give me 20C over 5D. And y'all remember, I said simplify each rational expression before you go further. A lot of y'all try to skip a step and do all of this next step at once. Notice how I'm doing the first fraction first. This one I need to multiply by d over d. So that rational expression is going to become 8d squared, because remember we add the exponents, over 5d. Denominators match, so we keep the denominators. We add across the numerators. In this case, there are no like terms. They're different variables, so there's not a correct order to write it in. So I have 20 minus 8d squared. Now, once it's a single fraction, you want to ask yourself, can you factor anything out of the numerator? I could pull a 4 out of the numerator, but that is not going to reduce with the denominator, so that is my answer. If you did pull the 4 out, that's okay. It will still work. Please just be careful. You cannot reduce the 20 and the 5. If you find yourself doing that, again, put the parentheses there. So we're going to go to number 18 now. Number 18, looking again at the LCD. Pause this and see if you can do it. My answer here should be 3x squared. There's nothing in common with the 3. I've got to bring it over. There's an x in one rational expression and x squared in the other. We take the maximum amount of times it occurs, so we need to use 2 of them. So we're going to keep it once we get it. So I'm going to multiply the first fraction by nothing, because notice it already matches. So this is already done. The second rational expression I need to multiply by 3x, numerator and denominator. So I'm just going to bring down the first rational expression. Didn't have to do anything there. The second rational expression, I need to multiply 16 times 3. That will give me 48. Denominator will be 3x squared. So again, stop and realize what I just did there. I just did 16 times 3. That's going to give me the 48x over 3x squared. Don't cross anything out here, because again, remember your goal. Your goal is not to cross anything out until it's a single fraction. So now the denominators match. We keep the denominator. We add the numerator, and in this case, if we scan it, be careful. Nothing is a like term, and I'm going to go ahead and put it in descending order. This would be 48x plus 14. Once it's a single fraction, ask yourself, can I factor anything? I could pull out a 2 in the numerator of both of those terms, but that's not going to cancel with the denominator. But you always should ask yourself, will it? Because the one time you don't will be the time that it does work. So you could also write that as 2 times 24x plus 7 in the numerator over 3x squared. So go ahead and pause 19, see if you can work it out. The mistake people make on number 19 is they think, all right, well, I'm just going to go ahead and use 2 minus x and x minus 2. Remember what I've told you all along. If we see something in what I call not in descending order, not in the correct order, we need to rewrite it. So this would be a negative x plus 2. That then means that I can pull out a negative 1 to change that, because we never leave a negative in the front of my binomial. So again, she's going to just kind of go directly to that piece and skip the middle step. I think most of you will make mistakes doing that way. So I think it's better to think of it, let's put it in the correct order first, then pull out the negative 1. Use factoring to pull that negative 1 out. Now if we look at this, there's 2 different ways to do it. You could use negative 1 times x minus 2 as your LCD. That works, and it will be acceptable. However, remember, the rule says if we have a negative in a fraction, we can move the negative in front, or we can move the negative in the numerator. So that's what I'm going to do here. I'm going to rewrite this as negative 3 over x minus 2. So it didn't look like it, but this problem actually has the denominators already matching. So my LCD is x minus 2. I had to manipulate it, but they match. So we keep the denominator. We add across the numerator. Negative 3 plus 1 will give me a negative 2. Put those parentheses around the denominator so you don't fall into that trap of canceling the negative 2's.